Maybe a great idea if we gave you a full example of what's really going to take place tonight when Jazz the Philharmonic unveils itself to the stage Carnegie Hall audience. That's wonderful, wonderful.
I do good for good's sake, with no thought of compensation. And I've evolved to the point where I don't care a thing about getting rewards. I'm not an atheist, but I behave as an atheist. I do good for good's sake, with no thought of compensation. And thus I've evolved to the point where I don't care a thing about getting rewards.
Hello. How you doing? I'm David Patterson with Dell EMC. I've been working with OpenStack for about 5 years now, mostly concentrating on edge computing for the past, say, 8 or 10 months. And we're here to talk about content caching at the edge. My associate here is Mark Biero.
Hi, Mark Birrell. I work for VMware now, but David and I were colleagues about 6 months ago, and this is when we started this entire project, or a little bit longer than that. So I've also been involved with OpenStack and various hypervisors for 10 years or so now, and have recently been looking a lot at edge computing, edge use cases, and we're here, to talk about the content caching use case.
So basically, what is content caching? It's optimizing performance, right? So instead of fetching large objects across the web, you're bringing the data closer to the user, enhancing performance. Why it's important? You want to reduce backhaul. You don't want everybody to have to continually get the same large files over and over again from some remote location. If it's more proximate to the user, you can reduce backhaul, therefore reducing cost. OpenStack right now allows you to provision bare metal nodes over L3 using Tripleo, Ironic, and routed L3 networks. We'll go over a example prototype where I have a simple reverse proxy server, Squid, which is set up as an accelerator that shows you how you can set up a basic, very simple, basic caching framework.
So a little bit on content caching and what the sort of edge use case is at a more general level. The concept of content delivery networks has been around for a long time. The idea there being you want to move content to a geographic or network location that's closer to the end user in order to reduce the latency and the demand on the origin source of all of the the video or whatever content it is that you're providing. So this fits very naturally in an edge use case because all we're doing is we're moving the CDN from being sort of geographically dispersed even closer to a radio network, as an example, to bring the content closer and improve the overall user experience. As mentioned here, typically it was data center or larger hops back, but now we want to start reducing that backhaul traffic and be able to replicate the content because, as typically has been shown, 80% of the consumers watch only about 20% of the content. So that hot content is something that you want to be able to move closer, and you won't have to be continually backhauling all of that traffic. I think I jumped ahead a little bit on myself here about this, but the 5G edge use cases are trying to address specifically that, about how are we going to get lower latency, and as well, now that we've got compute resources at the edge, we can actually do things like video transcoding at the edge. So if a cellular connection happens to be somewhat poor, we can actually retranscode on the fly and send a lower bit rate to that particular subscriber and a higher bit rate to another subscriber who happens to have a better plan or is closer to the radio or whatever the conditions are. So you can actually start dynamically changing your content and responding to your network and your customer needs right at the edge. Now, of course, this is going to mean an explosion in the number of edge nodes that you have, so there's potentially thousands of them, if not tens of thousands, that are going to go out there.
So right now there's lots of different projects going on with OpenStack in the edge. You got Starling X, you got Tripleo and distributed compute nodes, which is the use case that we're covering in particular here we're using. And also the Edge Working Group, which we've come up with some minimal viable products for doing such an architecture.
I'm actually just going to hop in for 1 second. For those who aren't aware of the concept of distributed compute node, the idea there is that your central control plane is actually at a central site, and your edge site is not a full OpenStack deployment.
That's right, and you'll see in the diagram as we move forward.
Yeah.
So as I mentioned, DCN, distributed compute nodes, allows you to provision nodes over L3. So you don't have to do L2 provisioning. It leverages Ironic, Neutron, routed networks, and availability zones are the key. So each site would be deployed as its own availability zone. So when you're deploying instances, you just specify the availability zone, and it would send it to that site. So while you can use virtual machines and containers for this kind of thing, the question is, why do you want to add that additional overhead? If the box is only concerned with doing video transcoding and things like that, bare metal seems to be the best fit. So here is the prototype that I set up in the lab. You can see here, we have the central OpenStack cloud. And here we have a remote site that this node was provisioned over L3. And then here we have the bare metal caching nodes. And as you can see here, we got the client over here would make a request for, say, a video on YouTube or some other content, and would be redirected to the caching node. The caching node would then fetch the content from the CDN and then populate it at the caching node. So the next time the client, a different client requests the same content, it's pulled from the local caching client. So this is a very simple type of architecture. There are more features around this area here where it would detect where you're coming from and tell you which would be the best edge site to go to. But this is just a very high-level kind of view of why you would want to do this kind of architecture. Some of the resources that you can find more information around this kind of thing is the Edge Computing Group, which I'm part of. Tripleo, Starling X, which is another Edge project, the Streaming Video Alliance, which has APIs that are specifically around what I'm describing, but at a higher level, which would also give you the ability to point you to the right site. And Squid, which was used for this prototype. Apache Traffic Control is somewhere in between the Streaming Video Alliance and Squid. But they have their own API. They don't necessarily abide to the Streaming Video Alliance's specifications yet, but Quilt does. And Quilt is a commercial offering for a video caching service, which they actually worked with the Streaming Video Alliance to define the specification for caching content. That was it. Does anybody have any questions? Nothing? Okay.
Awesome.
Well, thank you very much.